Hello students, in my last lecture I had explained you the image formation by convex lens. Today we shall see image formation by concave lens. So like convex lens, in concave lens there are not 6 cases. For concave lens we have only 2 cases. So in first case see, if the object is at infinite distance. See, suppose this is a concave lens. This is optical center. This is principal axis. Optical center. This is focus 1. This is f2. This is 2f1, and this is 2f2. If object is at infinite distance, then rays of light coming from the object parallel to the principal axis after refraction diverge in such a way that it appears to come out from a point. So this is incident ray, this is refracted ray. Really this ray after refraction diverge. Once again, suppose this is ray of light coming from infinite distance after refraction. It diverges in such a way that it appears to come out from a point. So, see, this is a real ray, and these rays of light after refraction diverge. So, there is not any possibility to meet these rays really. In such case, virtual image is formed at f1. So, in this case, what is the position of the image? Image is formed at f1. It is virtual, erect and highly diminished, that is point size. And second case, if object is at any point between optical center and infinity. So suppose if object is at any point between optical center and at any point. Suppose this is our concave lens. This is optical center. This is principal axis. Suppose this is focus 1, f1, 2f1, f2, 2f2. Object is taken at any point. Suppose this is the position of object. This is our object AB, and we take a ray parallel to the principal axis. What happens after refraction? This ray diverges in such a way that it appears to come out from a point. Really this ray diverges. This is incident ray. And we take second ray passing through its optical center. Second ray passing through its optical center. So this is incident ray, this is a refracted ray, and the rays of light passing through optical center don't change their path. They propagate on their original path. So what we see? We see that these two rays virtually meet here because one ray is real but another is virtual. So if this is object AB, then A dash B dash is the image of the object this image is virtual, erect and diminished. And as I had stated you, the synopsis, that is the position of the object, position of image, nature of the image and relative size of the image, all these things are given here for all these two conditions. So in table 10.5 of NCERT, see image formation by concave lens. First case, object is at infinity. See here, object was taken at infinite distance. What is the position of the image? Image is formed at f1. See here, in this chart also it is given, position of the image is at focus f1. What is the size? Highly diminished, that is point size. See here, the size of image is highly diminished, that is point size. And what is its nature? It is virtual, erect. So see here, nature is also given here, virtual and erect. Also for second case, see, what is the position of the object? Between infinity and optical center A of the lens. In this case, see, object may be taken at any point between optical center and infinite distance. Then see, what is the position of the image? Between focus and optical center. See, the position of the image is between focus and optical center. What is its size? It is diminished. And what is nature? It is virtual and erect. So see, here given, size of the image is diminished and nature is virtual and erect. So for our consideration, all positions, that is position of the object, position of the image, size of the image and nature of the image is well tabulated in table 10.5. So for your consideration, for your revision, this table is very important. All important informations related to concave lens is given in 10.5. Similarly, we see that all informations regarding image formation by convex lens is given in table 10.4 NCERT page 178, which we had discussed in our previous lesson. So now we are able to draw ray diagrams with the help of convex and concave lens both. Next thing is sign convention for spherical lenses. It is very important. Sign convention for spherical lenses. Spherical lenses. Spherical lenses means for both concave and convex lenses. Spherical lenses. And dear students, remember in my lecture 7 and 8, I had given you complete information about sign conventions related to spherical mirrors. And I had said you that this convention is also applicable for lenses. So once again recite what we had learnt. We had learnt that in the case of a spherical mirror, the role of pole just behaves like as the role of origin in coordinate planes. So suppose we have this Cartesian plane, x dash, y dash. Suppose this is x dash, y dash. This is origin. And we have read already two lenses, spherical lenses, that is convex lens and concave lens. In both lenses, we have well-defined optical center, principal axis, etc. So suppose this is optical center. Now, remember that concept which we have already learnt for spherical mirrors. What we have learnt? We have learnt that the pole of a spherical mirror just behaves like as origin of Cartesian plane. Here, the optical center of a spherical lens just behaves like origin. Now, according to new sign convention, all objects are taken left to the mirror or lens. Now, the next point was that the distance measured in the direction of incident ray is taken positive, and the distance measured in opposite direction of incident ray is taken negative. So, for lenses, we shall measure all distances from optical center, and the distance measured parallel to the principal axis in right of the optical center will be positive, and in left will be negative. Similarly, see here, this distance will be positive, in this direction distance will be negative, and the distance above x-axis and parallel to y-axis, this is positive, and below it is negative, which we have already seen for spherical mirrors. Here also all distances above principal axis will be positive, and distances normal to the principal axis and below it will be taken negative. So, obeying these concepts, which we have already discussed for spherical mirrors, our numerical problems will be very confident to us. So, with using all these concepts, we can solve numericals related to lenses easily. So, what are the now points related for the solution of numericals related to lenses? We have again two very important formulas, and these are lens formula and magnification. So, see, what is lens formula? Lens formula. For mirror, what we had seen? We had seen 1 by V plus 1 by U is equal to 1 by F. But for lenses, what is the formula? 1 by V minus 1 by U is equal to 1 by F. Here is slight change. For mirrors, we had taken 1 by V plus 1 by U is equal to 1 by F. But for lenses, we shall use 1 by V minus 1 by U is equal to 1 by F, where U is object distance, like prior. All these things are just like our spherical mirrors. V represents image distance, and F represents focal length. What is magnification? Second thing is magnification. We have already seen what is the definition of magnification. For spherical mirrors, the same definition is repeated here. That is the ratio of height of image to the height of object is called magnification. That is M. Magnification M is equal to H dash by H, where M is magnification, H dash is height of the image, and H is height of the object. Now, the second formula for magnification is M is equal to V by U. So see, there is some very slight change for the formula of magnification in the case of lenses. For mirrors, what we had seen? We had seen magnification M is equal to minus V by U. But for lenses, it is V by U. And here, in lens formula, it is 1 by V minus 1 by U is equal to 1 by F. So there should not be confusion in mirror formula and lens formula. Formulas are different. So do proper practice of these things. As I have seen continuously during solving numericals, students usually use lens formula in place of mirror formula and mirror formula in place of lens formula, and everything becomes very negative. So revise it properly. What is mirror formula? What is lens formula? But the concept of magnification is the same. That is, it is the ratio of height of image to the height of object. Once again, see, one thing is very important, that if magnification is positive, like the mirror, if magnification is positive, then magnification is positive, which indicates that h dash and h both are positive. And when h dash becomes positive, when image forms a principal axis, because height of object is always positive, but height of image becomes positive only for virtual images. So if magnification is positive, then the nature of the image will be virtual and erect. But if magnification m is negative, so what we have seen? We have seen that magnification m is equal to h dash by h. H always remains positive. So if m is negative, which indicates that h dash is negative, that is height of image is negative, and height of image becomes negative for real images, because real images always form below principal axis. So if m is negative, then what will be the nature of the image? Then the nature of the image will be real and inverted. By using these concepts, we can easily solve numericals. So, before concluding my lesson today, I shall give you homework that revise and learn the lesson and draw diagrams for image formation by concave lens. Thank you very much.